So we have a new chapter called Inverse Trig, and here's what it's about. Imagine for a moment that you had a friend who was being towed behind your speedboat here. Here's your speedboat, and your friend's up here because they have got like a kite on their back, and they're flying up above Lake Minnetonka. They're kite skiing. All right, so anyway, they're 10 feet off the lake. And it's a 20-foot long line. And so then the question would be, what's this angle right here? You may remember we can set up a trig equation for that. So that's like sine of some angle I don't know is equal to opposite, which is 10, over hypotenuse, which is 20. And of course, that'll simplify to just 1/2. Now, have I done any inverse trig? No, not at all. I've just done regular trig here. But if you were going to solve for that angle, now I know some of you are like, I know the angle. But if you don't know the angle and you had to solve for the angle, this is the part where you'd use inverse trig to solve it. So I like to show that this way. So if I was going to solve this, I can, let me see if I can move this over my 10/20ths. And I know you know that I can reduce 10/20ths to 1/2. And I know that I didn't just randomly pick those numbers. I picked one that would work out nice. But of course, if you used a calculator, those lengths could have been anything. You know, it could have been 35 feet behind you and 17 feet above the water. But I picked nice numbers so that when I go inverse sine, see how inverse sine is going to undo sine, and inverse sine, the sine with the little -1 right there, that's inverse sine. Okay, inverse sine cancels off sine, and then I have theta equals sine with this little -1, that's called inverse sine, of 1/2. And that's what you could type into your calculator. I know you know that on your calculator you have spots for inverse sine. It's, of course, right above sine. And just to clarify, this is not the same as sine has a flippin' sister, I call it. If sine of some angle is 1/2, then cosecant of that angle is 2/1. This is not that. Okay, so a lot of kids get that in their head. They're like, oh, so this is the one where you flip sine over. Nope. That's different. That's a reciprocal. Okay, this is inverse trig. So we are not talking about this kind. All right, so if you were to put this in your calculator, inverse sine of 1/2, you'd be doing inverse trig. And what would you get for an answer? Well, I happen to know that one, but I'm going to show you just a little bit more about what it would mean. Okay, so now inverse trig has some special rules of where you can do inverse trig and where you can't. All right, so inverse sine is only allowed to happen between here and here. And that's between, let me draw this in here, -pi/2 and pi/2. I'll show you later why that is, but inverse, and you should take notes on this, by the way. This is where inverse sine is allowed. All right. Inverse cosine is allowed all the way across this top quadrant here. That's where inverse cosine is allowed. And that's from 0 to, I hope you remember that that's where pi is. And the last one is tangent, and tangent happens to be really close to sine. But you may remember tangent has asymptotes on it. If you look at the graph of tangent, remember how it has asymptotes, and that means you can't touch the edges. So the same idea for inverse tangent, it goes like this, but it cannot touch that line. Okay, whereas sine can touch that line. So it can go right up to and touch that line at -pi/2 and at pi/2. Okay, the blue one, which is inverse tan with a little -1, inverse tangent is only allowed between -pi/2 and pi/2 also, but it can't touch because it's got asymptotes on the end. All right, so what did I just say there? Your inverse trig has to live in certain quadrants because of how it looks. All right, so now I'm going to give you a quick reminder of how regular sine looks. You know regular sine looks like this, right? And it goes on forever. It keeps going, and it keeps going. And if I wanted to get an inverse A quick reminder about what an inverse means. An inverse means you'd have a reflection over the line y equals x. And then this thing would flip. An inverse is the y becomes the x and the x becomes the y. And it starts doing this. And it would keep going in both directions. But we can't allow that to happen or it wouldn't be a function. Oh, so much interesting information here. I know you know that a function has to pass the vertical line test. So see that little red part that I drew there? That's why in the next video you watch, they're only going to go to pi over 2 and negative pi over 2 because otherwise it wouldn't pass the vertical line test. All right, so a typical, you're going to have a supplementary video to watch after this one, but a typical question just boils down to look kind of like this. So imagine for a moment that they said arc sine of 1/2. What on earth does that mean? Well, that means they started with sine of some angle was equal to 1/2, and then they took the arc sine on both sides. And arc sine, by the way, means the exact same thing, except usually it means you should do it in radians, okay? It means the exact same thing as sine with a little -1. So I'm going to write it this way too. If I say sine -1, and I do it to both sides, that's inverse sine, okay? And that's canceling this out, and there I have it again. That theta, my angle, will be the inverse sine of 1/2. Now, did you remember that I picked numbers that were really nice? This one is 30 degrees. You probably know that sine of 30 degrees is 1/2. So get used to writing these backwards. They'll start out by saying arc sine, which this means the same thing as inverse sine of 1/2. So if I had this, I suggest to all my students the first thing you should do is rewrite this and say, so you're saying you want the sine of some angle to be 1/2. The only thing is that normally wouldn't this have two answers? It would normally have two answers because, you know, sine is positive in this quadrant here and sine's also positive in this quadrant here, so it should have two answers. But do you remember that inverse sine is only allowed from here to here? Okay, so see how it's only going to have one answer? It can't use that one because inverse sine is only allowed from -pi/2 to pi/2 because otherwise its graph wouldn't pass the vertical line test. Okay, pretty deep stuff. But how do you actually answer the question, Mr. Server? All right, so if they gave you this as your question, you would first start by writing it like this and saying, okay, so they're asking for an angle, but I got to remember I've got the rules of inverse sine, which is I can only give them an answer that's in this quadrant or in this area. Okay, and so that means only one of the quadrants would work, quadrant 1, and so I just want the quadrant 1 answer for it. And so I like to draw the triangle for it. So here's my triangle. I'm going to set it up with sine is opposite over hypotenuse, right? Opposite, hypotenuse. The third side, oh yeah, it's the 1, 2 squared 3 triangle. Oh, I know this one. It's the 30-degree angle. And so the answer is 30 degrees. So whenever you have an inverse sine question, it's a question of, hey, what's the angle for this? All right, so the angle they want here is 30 degrees, also known as pi over 6. I'm going to put a little or in there. You can answer either way. Now, if they had said arc sine, you would for sure want to answer in radians. And if they just leave the little -1 here, then you can use degrees. That's the way we're doing it. Other teachers do it different ways. So, okay, so there's your intro to the basics of what inverse trig is about, and it's all about finding an angle, and they're rewriting it. So you're used to this way where we would have the angle right here, and this way of writing it is asking you to figure out what the angle is equal to. So it's solved for the angle. So you're trying to figure out what the angle is, and they've given you the sides. All right, there's your intro. Have a great day.